Hello students, in this video we're going to learn about domain and range of functions, how to find it analytically. Okay, so later in another video I will explain how to find it graphically. Now I strongly recommend that to understand this concept better you need to know what a real number is. Okay, I hope you know, like we talk about integers, natural numbers, starting with natural numbers, and then we have whole numbers, then we have integers, then we have rational numbers and irrational numbers. So all these put together forms a set of all real numbers. Okay, so you need to know what a real number is before to understand this what I'm going to explain in this video better. Okay, so I have prepared another video on this titled real number, so please do watch it. But if you are clear, if you know what a real number is, then you can watch this video. Okay, now before I go ahead and tell you how to find the domain and range of functions, let me just briefly explain what a function is. So now let me consider a function, for example, f of x equal to x plus 3. I can also write it as f colon x arrow x plus 3. So what does it mean? So you know that function is actually a rule by which every element in the first set is assigned a unique element in the second set. Now what do you mean by that? Okay, so normally I use this diagram to explain the concept of functions, and students I feel they find it easier to understand when you do this. Okay, so let me use the same diagram for you. Okay, so this we have is the input and this we have is the output. Okay, you have input and output, and please understand something. The input and output, both of them have to be only real numbers. So we are not talking about any other non-real number. So the input and output has to be only a real number. Okay, now for example here the input is x and the output is x plus 3. Okay, so if you put x inside you will get x plus 3 outside. Okay, for example if I put 1 inside then you'll get 4 outside, isn't it? Because how do I know I get 4 outside? Because f of 1 is 1 plus 3, which is actually 4. Sorry, 4. Yeah. So if I put 1 inside, I'll get 4 outside, which is a real number. Now if I put, for example, 0 inside, as you can see, I'll get 3 outside. Yeah. Okay. One thing you need to understand is 3 is a real number, isn't it? It's very, it's an integer, it's a natural number, whole number. It's also a real number. Okay. Let me put root 2 inside, which is actually an irrational number. So we'll get root 2, the output will be root 2 plus 3, which is again a real number. Okay, so whatever you put inside here, the input, this forms the domain. The set of all these numbers that you put inside forms the inside. So basically input is the domain, and what you get outside, the output, is actually called as the range. Okay, so you have a domain and then you have a range. So input is domain and the output is range. So as I told you earlier, you can only put a real number inside and the output should also be a real number. So you may ask me, sir, is it possible that the output is not a real number? Can you give an example? So let me give an example for that. Okay, so let us consider, for example, f of x equal to x over x minus 2. Okay, so that means the input is x. So let me, for example, input. So this is the input and this is the output. Okay, if I put 0 inside, then I will get 0 outside, isn't it? Because f of 0 is 0 upon minus 2, which is again 0. Okay, so in case if I put 1 inside, then what will I get? Then I'll get 1 by minus 1, which is actually minus 1. So you'll get minus 1 outside. Okay, now what will happen if I put 2 inside? Suppose if I put 2 inside, then what will I get? Let me find out. So f of 2 will be 2 upon 2 minus 2, which is actually 2 upon 0. Okay, so now we know that 2 upon 0 I'm sorry, I think I've used an eraser. So here 2 upon 0. Okay, let me write it properly. So we have 2 here, so 2 upon 0. Okay, now we know that this 2 upon 0 is not a real number, isn't it, students? It is not a real number, because you cannot divide a non-zero number by 0. So it is not a real number. So what it means is, if I put 2 inside, there won't be any output, because as I told you, the output has to be a real number. So basically what it means is, you cannot put 2 inside, as simple as that. Even though 2 is a real number, but since it doesn't give you an output, you can't put 2 inside. So for this function, the domain, when you find the domain of this function, the domain is all real numbers except 2. So the domain is all real numbers except 2. So why is it except 2? Because if I put 2 inside, I won't get a real number outside. So basically for this function, the real number is all the domain is all real numbers except 2. Okay, so I hope sort of you understood sort of about the domain and range a little bit. So let us see more examples. So I'm going to start with polynomial functions first. So let me take f of x equal to let's say 2x plus 3. Okay, so the input is x and the output is 2x plus 3. I can also write it as f colon x arrow 2x plus 3. Okay, so this is a linear function. I hope you know what a linear function is, right? Okay, now I want to find the domain of this linear function. Now you may notice that whatever I write, substitute for x, like for example, let's say f of 1, then I'll get 5, which is the output, which is a real number. So if I find f of 0, again it is 3, again it is a real number. So let me find f of root 3 is 2 root 3 plus 3, again a real number. So whatever real number you substitute for x, you will always get a real number as the output. So basically for this function, the domain is R. That means all real numbers. Okay, so for this function, for a linear function, the domain is all real numbers. So whenever you in future, when you see a real linear function, you can close your eyes and say that the domain is all real numbers. As simple as that. So let me take a quadratic function. Let me erase this first. So let me say f of x equal to x square plus 1, for example. Okay, I have taken a quadratic function without an x term. Now here also, whatever you put for x, okay, I know I'm using the word put actually so that you can understand it better. Whatever you substitute for x, whatever real number you substitute for x, you will always get a real number outside. For example, if I put f of 0, then I'll get 1 as the answer, which is actually a real number. So if I write f of root 2, then it will be root 2 square plus 1, which is actually 3, again a real number. So whatever real number you write for x, you replace with x, you'll always get a real number outside. So for this function also, the domain is all real numbers. Okay, now it is not true only for this x square plus 1, it is true for any quadratic function. So even if you say, for example, f of x equal to x square plus 2x plus 3, for this also the domain is all real numbers. So for every quadratic function, the domain is all real numbers. So let me take a cubic function now. So let us say f of x equal to x cube plus 2x square plus x plus 1, for example. Okay, now again for this cubic function, whatever number you replace, whatever number you substitute for x, whatever real number, you'll always get again a real number outside. For example, if I want to find what is f of 0, then I'll get 1 as the answer, right? If I want to find what is f of 1, then I'll get 1 plus 2 plus 1 plus 1 which is nothing but 5. Okay. So again, for this function, the domain is, domain, let me write it properly. The domain is all real numbers. Okay. So for a linear function, the domain is all real numbers. For a quadratic function, the domain is all the real numbers. And for a cubic function also, the domain is all the real numbers. In fact, for any polynomial function, okay students, for any polynomial function, the domain is all real numbers. Okay. So for any polynomial function, the domain is all real numbers. So it's very, very simple. Okay. So I'm not going to deal with the fourth degree function of polynomial of degree 4 or polynomial degree 5 like that. So I'm not going to go into that. So let me give you different types of functions. Let us go to rational functions. Now you may ask me, what is a rational function, sir? Okay, for example, any function that can be written in the form h of x by g of x, where h of x and g of x are polynomials. Okay. So if h of x and g of x are polynomials, and if I write h of x by g of x, then it is a rational function. To give an example, let's say x by x plus 2 is a rational function. Another example is, f of x equal to, I just give it a name. For example, f of x equal to 3 over x square plus 1, again a rational function. Or another example is, let's say x square minus 1 by x cube plus x. So these are all rational functions. So what I'm going to do is, we're going to find the domain of simple rational functions. Okay. Let me clear everything. So let me give an example. If f of x equal to x over x, okay, let me write it properly, x over x minus 1. Okay, now here students, you know that if the denominator is 0, then it is unreal, isn't it? So here, for this problem, you cannot find f of 1. Let us say f of 1, you will get 1 by 0, which is not real. So that means for this function, the domain is all real numbers except 1. You may ask me, sir, but is 0 part of the domain? Yes, definitely. Let me find f of 0. F of 0 is 0 upon minus 1, which is actually 0, again a real number. So 0 is part of the domain, but 1 is not part of the domain because it won't give you an output. 1 by 0 is not a real number. So you may ask me, so how do I easily find out the domain? Very simple. Whenever you see a rational function, you first consider the denominator. In fact, if you just consider only the denominator, what value should I put for x so that it becomes 0? Now, for example, here I should put x as 1 so that it becomes 0. So it means that 1 is not part of the domain. So let me give you another example to make you understand this concept better. So let us say f of x equal to x square plus 1 by x minus 3. Now here, look at the denominator, students. It is x minus 3. Now here, if I substitute x as 3, the denominator will become 0, isn't it? So for example, when I try to find f of 3, you will get 10 by 0, correct? So which is not a real number. So basically 3 is not part of the domain. So for this function, the domain is, let me write in future, I'm going to write domain as capital D, okay, for convenience. The domain is all real numbers except 3. Okay. You may ask me, sir, is there an easier way to write this? Yes, you can also write like this. Let's say x belongs to R. The domain is x belongs to R, where x is not equal to 3. Every real number except 3. So let me give you another example. So let us say let us take f of x equal to x square by x plus 4. Okay, here it is easy to note that if I replace x with minus 4, for example f of minus 4, I'll get 16 upon 0, which is not a real number. Therefore minus 4 is not part of the domain, correct? So that means for this function the domain is all real numbers except minus 4. Yeah, okay. Let me take another example. Let's say f of x equal to x over x square minus 4. Now here you may notice that f of 2 is 2 upon 0, right? And f of minus 2 is also, it is actually minus 2 upon 0. Now again both of them are unreal. So for this function the domain is all real numbers, x belongs to R, but x cannot be either 2 or minus 2. So all real numbers except 2 or minus 2. So how do I find out straight away it is 2 or minus 2? Very simple. Take the denominator, so x square minus 4, and equate it to 0. X square minus 4 is 0, so x square equal to 4. That means x equal to plus or minus 2. That means if I put x as plus or minus 2, the denominator will become 0, so it cannot be part of the domain. Another example. So let us say f of x equal to 3 by x square minus 2x, let's say minus 3. Okay, now I want to know what is the domain of this function. So it is in the rational function. So look at the denominator. So take the denominator, so equate it to 0. X square minus 2x minus 3 equal to 0. So when you solve it, you will get x as either 3 or minus 1. So what does it mean? When I substitute x as 3, the denominator will become 0, or when I substitute x as minus 1, the denominator will become 0. So let me cross check. F of 3 is 3 upon 9 minus 6 minus 3. So which is nothing but 3 by 0. So again you can see that it is 3 by 0 is an unreal number. So for this function the domain is all real numbers, x belongs to R, but x cannot take the values 3 or minus 1. Okay, so let us see another example. F of x equal to x by x square plus 2. Okay, now consider this rational function, students. Now here I want to find out the domain. Okay, so let me equate the denominator to 0, because the denominator cannot be 0, isn't it? X square plus 2 is 0. That means x square equal to minus 2. Now we know that if x is a real number, then square can never be equal to minus 2, isn't it? No real number, when you square it, will give you minus 2 as the answer. So what does it mean? It means that this denominator will never become 0. Whatever you replace it, you substitute for x, the denominator will never ever become 0. So what it means is, for this function the domain is all real numbers. So that means x belongs to R. Okay, so for this function the domain is all real numbers. Okay, so a final example of a rational function, then we'll move on to the next type. So let me take f of x equal to x over, let's say for example x cubed minus 8. Okay, so now I want to find the domain of this function. So again, if it is a rational function, consider the denominator. So let me take the denominator, which is x cubed minus 8, and I want to find out, is there any value of x which will make the denominator 0. So that means you equate it to 0. So x cubed equal to 8. So that means x equal to 2. So what it means is f of 2 will be 2 by 0. isn't it? So therefore 2 is not part of the domain. So for this function, the domain is all real numbers. So how do you write it? Okay, let me write it this way. The domain is x belongs to R, but x cannot be 2. So all real numbers except 2. So I hope you understood how to find the domain of rational function. So first we saw the polynomial function where the domain is all the real numbers. Then we saw rational functions where the domain is, in some cases, domain is all real numbers. In certain cases, domain is all real numbers except few numbers, which will make the denominator 0. So let us go to the next type. Let us take square root function. Okay, let me take f of x equal to root x. Okay, we know that square root of any negative number is unreal, isn't it? For example, square root of, let's say, minus 3, it is not a real number, right? You cannot find a square root of a negative number. So for this function, so what it means is f of minus 1, for example, root of minus 1 is not a real number. That means minus 1 is not part of the domain. Let me find f of minus 1.3. Again, root of minus 1.3 is not a real number. That means minus 1.3 is not part of the domain. So in fact, every negative real number is not part of the domain. So for this function, you cannot put x as a negative number, right? So for this function, the domain is x belongs to R and x is greater than 0. Or you can simply write x greater than 0. Okay, it is understood that if you don't write it, it means x is a real number. So basically, every real number, in fact, you can include 0 as well. Okay, you can include 0. So every non-negative real number. Okay, so let me take another square function. Let me take f of x equal to root of x minus 3. Okay, now here when I try to find f of 1 will be root of 1 minus 3, root of minus 2, not a real number. Therefore 1 is not part of the domain. So if I want to find f of 2, for example, root of 2 minus 3, root of minus 1 is not equal to R. Again, 2 is not part of the domain. So how do I find out easily, sir? You may ask me, how do I find out easily? Very simple. Whatever is inside the square root, for example, x minus 3, okay, this should be greater than or equal to 0, isn't it? For it to be a real number. That means x has to be greater than or equal to 3. So that is the domain. That is the domain. So the domain is all real numbers greater than or equal to 3. Okay, let me take another function. Let's say f of x equal to root of x plus 4, for example. Again, x plus 4 has to be greater than or equal to 0, isn't it? To get a real number. So therefore x has to be greater than or equal to minus 4. So therefore the domain is all real numbers, x belongs to R, and x has to be greater than or equal to minus 4. That means you cannot find an image of any real number less than minus 4. Okay. So for example, you can't find f of minus 5. Let's say, what is f of minus 5? F of minus 5 is root of minus 5 plus 4, which is root of minus 1, which is not a real number. So minus 5 is not part of the domain. Okay. So let us see a few more examples. So f of x equal to, let us say for example, root of x square minus 9. Okay. Now here, x square minus 9 should be greater than or equal to 0. That means x squared has to be greater than or equal to 9. Okay, we know that x square will be greater than or equal to 9 when either x is greater than or equal to 3 or x is less than or equal to minus 3. For example, take minus 4. When you square it, it will be greater than 9. If you take 4.1, again when you square it, it will be greater than or equal to 9. Greater than 9, in fact. So for this function, the domain is, I can write it as x greater than or equal to 3 or x less than or equal to minus 3. So you can input any number greater than or equal to 3 or any number less than or equal to minus 3. But you cannot put a number between minus 3 and 3. For example, so if I want to explain using a real line, okay, so let's say this is a real line. So here you have 3, here you have minus 3. So this is part of the domain and this is part of the domain. Now this part that you see here between minus 3 and plus 3, it is not part of the domain. To make you understand better, let me take a number here. Let's say 1 here. So f of 1 will be square root of 1 square minus 9, which is 1 minus 9. So square root of minus 8, which is not a real number. Okay. So for this function, the domain is all real numbers greater than or equal to 3 or less than or equal to minus 3. Okay. So one more example, square root function. So f of x equal to square root of let us say 4 minus x square. Again here 4 minus x square should be greater than or equal to 0. That means x square should be less than or equal to 4. So when will the square of x be less than or equal to 4? When x lies between minus 2 and plus 2. So if we take any number between minus 2 and plus 2 and square it, the square will be less than or equal to 4. So this is the domain of this function. Okay. So one more example, f of x equal to square root of x square plus 2. Now here this x square plus 2 should always be greater than or equal to 0. But we know that x square plus 2 will always be greater than or equal to 0, isn't it? This is true. This is true for every real number. That means whatever number you replace, you substitute for x square plus 2 will always be positive. Therefore, for this function, the domain is all real numbers. Okay. So I hope you understood. Okay. So we have seen a polynomial function, then we saw a rational function, now a square root function. So let us go to exponential functions. So let me take f of x equal to let us say 2 power x. Okay. Now here you may notice that whatever number you write for x, for example f of 0, which is 2 power 0, which is 1. So f of, let's say for example 3, 2 power 3, which is 8. F of root 3, 2 power root 3, again a real number. Okay, it is a real number. So whatever number you write for x, you will always get a real number as the answer. So in fact, for any exponential function, the domain is all real numbers. Okay. So finally, let us see a logarithmic function. Okay, let's say log x to the base 2. Okay. Now again, you know that logarithm is defined only for positive real numbers. Okay, not even 0. We say log 0 is minus infinity, which is actually not a number. So here x has to be greater than 0. Whatever the base is, this quantity should be greater than 0. So basically for this function, for this log function, the domain is all real numbers. So this is the domain. So suppose if I take, for example, f of x equal to log x minus 3 to the base 10, for example. Again, this x minus 3 should be greater than 0 because you cannot find logarithm of a negative number or a 0. Therefore, x is greater than 3. So for this function, the domain is all real numbers, but it should be greater than 3. All real numbers greater than 3. Or you can simply just write x greater than 3. Okay. So one final example. Then after that we'll move on to range. How to find range of a function. So let us say f of x equal to log let us say x squared minus 3 to the base 2. Again, this x squared minus 3 should be greater than 0. Okay, therefore the x square should be greater than 3. That means x should be greater than or equal to root 3 or x should be less than or equal to minus root 3. So this is the domain of this function. So this is the domain of this function. Okay. So I hope you're able to understand what I'm trying to say. So let us go to finding range of a function. Okay. So I'm going to teach you how to find the range. Now let us start with again a polynomial function, a linear function. So f of x equal to, let me take the same example, 2x plus 3. Okay. Now we know that for this function the domain is all real numbers. Okay, how do I find the range? Very simple. You replace f of x with y equal to 2x plus 3. Okay, then you make x as the subject. So 2x equal to y minus 3. So x equal to y minus 3 upon 2. Okay, you may notice that whatever value I write for y, like 1, 2, 1.1, 2, 3, 5, whatever it is, this y minus 3 by 2 will always be a real number, isn't it? Whatever value I write for y, it will be a real number. So that means the range is, in fact, y is part of the range, right? So range is y belongs to R. So it means for this function, linear function, the range is also all real numbers. So what do I mean by that? So you know that this is the first set, this is the domain, then you have the codomain. Okay, and range is actually here a subset of codomain. But here you see that every element here, for example, let's say for example 0 will have a pre-image. The pre-image will be minus 3 by 2, minus 3 by 2. Okay, and 5, the pre-image will be 1. Okay, because f of 1 is here, f of 1 is 5. So basically whatever real number I take, I can find a pre-image here. So basically for this function the range is all real numbers. Okay, let me take another example. Okay, I think before I move ahead, students, maybe I should explain this concept better to you. I said that for this function the range is all real numbers. Okay, so every real number is part of the range. Okay, then you may ask me, okay sir, let us say 10. Is 10 part of the range, sir? So for example, is 10 part of the range? Yes, definitely. So what I'm going to do is, here I'm going to write, this is the first set, this is the second set. Okay, so I'm saying this is the range, in fact all real numbers. So your question is 10, the real number 10, part of the range? Definitely. So how do I find out what is its pre-image? So what I'll do is, I'll write 2x plus 3 equal to 10. So x equal to 10 minus 3 upon 2, which is actually 3.5. So basically 3.5, which is a real number. So basically whatever number you take here, any real number that you take here, you will always find a real number in the first set, which is connected to this set. So basically every real number here, every number here has a pre-image. Okay, so to make you understand this better, what I'm going to do is, I'm going to go to a rational function. Okay, so let us say, let me take a rational function, f of x equal to x over x minus 1. Okay, now here we know that f of 1 is not defined, isn't it, students? So for this function here, if I draw like this, this is the domain, this is the domain, and this is the codomain, this is the codomain, codomain. Okay, this is actually set of all real numbers. Okay, now I want to find, so here this is actually, domain is the one doesn't apply, one is outside, isn't it? One is not inside the domain because it is not part of the domain. Now I want to find what is the range of this function, this f of x equal to x over x minus 1. Let us say I would like to say, let's say 0. Okay, can 0 be part of the range? Definitely. So here, in fact, you can find a pre-image here which is also 0, because if I put f of 0, I'll get 0 by 0 minus 1, which is actually 0. Okay, let me take another example. Let's say let us take 1.5. Okay, I would like to know whether 1.5 is part of the range. Okay, now 1.5 will be part of the range if you can find a number which is connected to 1.5. If you can find a number in the first set which is connected to 1.5. In fact, when you find f of 3 will be 3 by 2, which is 1.5. Yeah, you can find a number here in the first set. So 3 is connected to 1.5. So 1.5 is part of the range. Okay. Now you may want to know, is 1 part of the range? Is 1 part of the range? Let me find out. So how do we do that? What I do is, I need 1 as the output. That means what should be the input. So I'll write x by x minus 1. So I'll get x, I cross multiply x equal to x minus 1 and cancel x and x. So you'll get 0 equal to minus 1, which is absurd, isn't it? It is absurd. So what does it mean? That means this 1 is not part of the range. It will be in the codomain, but it is not part of the range. So in fact, for this function, the range is, I'll write it as range is all real numbers except 1. All real numbers except 1, because 1 does not have a pre-image. So let me show you another example. Let's say, so you said that the domain range is all real numbers. So let us say, let me take another example or another number. I'll erase this part. Okay, I want to know, let us say I want to know whether 2 is part of the range. So how do you know whether 2 is part of the range? So let me write, so I need output as 2. That means the x over x minus 1 should be 2. So x equal to 2x minus 2. That means x equal to 2. Yes, in fact, if I put 2 here, you'll get 2 here, right? So 2 is also part of the range. So for this function, the range is all real numbers except 1. Now, how do I find it? How do we find it? So I'm going to teach you a method. So please listen carefully. So let me go back to a linear function. A linear function, the domain is all real numbers. The range is also all real numbers. Okay, so let us, I won't go to the linear function. Maybe let me take a quadratic function. F of x equal to x square plus 2. Okay, now we know that for this function, the domain is all real numbers, right? For any polynomial function, the domain is all real numbers. Now, how do I find the range for this? Okay, here, okay, so this is actually y, isn't it? Y equal to x square plus 2. So I'll give you a very easy method to find the range. So basically, y is the range, right? So we know that x square will always be greater than or equal to 0, right? Square of a number is always greater than or equal to 0. That means x square plus 2 will always be greater than or equal to 2, correct? I'm adding 2 both sides. But we know that this x square plus 2 is nothing but y. So y is always greater than or equal to 2. So for this function, the domain is, sorry, the range is all real numbers greater than or equal to 2. Okay, so how do I cross check it? So let me draw the first set, which is the domain. Let me draw the second set, which is the codomain. I'll write it as D and I'll write it as CD, codomain. Okay, so I said that all real numbers greater than or equal to 2 form part of the range. Okay, let me do one thing. I'll write the second set, not as the codomain, but as the range. Range here, range. Okay, so let me say 3. Okay, I'd like to know whether 3 is part of the range. Let me find out. So I need the output as 3. That means x square plus 2 should be equal to 3. That means x square should be equal to 1. That means x is plus or minus 1. Yes, definitely. In fact, 1 and minus 1, both of them are connected to 3. Therefore, 3 is part of the range. Okay, I like to know whether 0 is part of the range. Let us say I write 0 here. I like to know whether 0 is part of the range. So that means 0 has to be the output. That means x squared plus 2 should be equal to 0. X squared should be equal to minus 2. But we know that this is not possible, right? Therefore, I have to erase 0. 0 is not part of the range. Okay. So in fact, let me take another example. Let's say I want to find out whether 1 is part of the range. So for that, how do I find out? I write this x squared plus 2. So x squared plus 2 equal to 1. Therefore, x squared equal to minus 1. Again, which is not possible. Therefore, 1 is not part of the range. So I have to erase this. So in fact, any real number greater than or equal to 2 is part of the range. Yeah. Okay, let me give you another quadratic function. So f of x equal to x squared minus 3. Now here again, we know that x square is greater than or equal to 0. I'll write this as y. So basically I want to know what values y can take. So x squared minus 3 should be greater than or equal to minus 3. Okay, why am I subtracting 3 from both sides? Because I want to get this x squared minus 3. So again, that means y is greater than or equal to minus 3. So this is the range. That means any real number greater than or equal to minus 3 is part of the range. But any number less than minus 3 is not part of the range. Okay, another example, f of x equal to, let's say 2x squared plus 5. Again, here x square is greater than or equal to 0 and 2x square is also greater than or equal to 0 and 2x square plus 5 is greater than or equal to 5. But we know that this 2x square plus 5 is nothing but y. So y is greater than or equal to 5. So this is the range. So y is greater than or equal to 5. The range is this. So what does it mean? That means if I draw two sets here, if this is the domain and this is the range, here only numbers which are greater than or equal to 5 is part of the range. Any number less than 5 is not part of the range. Because, for example, if you want to know why any number less than 5 is not part of the range, then for example, let's say I want to know whether 4 is part of the range. So how do you cross check? You write 2x squared plus 5 equal to 4. That means 2x squared equal to minus 1, again, which is not possible, isn't it? You can't have 2x squared as negative number. So that means 4 is not part of the range. Okay. What if you get a quadratic expression with the next term? Okay, so let's say f of x equal to x square plus 6x plus 2, for example. Now, how do I find the range of this quadratic function? Okay, you should watch another video that I prepared on quadratic functions. And in fact, I prepared a video on, if I'm right, the title is Completing the Squares. Okay, please watch the video. Now you can write x squared plus 6x plus 2 as x plus 3 squared minus 7. Okay, so that means, now how do I find the range from this? So this is basically the f of x, which is nothing but the y for me, the range. So we know that x plus 3 squared is greater than or equal to 0. That means x plus 3 squared minus 7 is greater than or equal to minus 7. That means y is greater than or equal to minus 7. So all real numbers greater than or equal to minus 7 is part of the range. So this is the range. Okay, one more example. Let's say f of x equal to 3 minus x squared. Okay, fine. How do I find the range for this? Now we know that minus x squared is less than or equal to 0, isn't it? That means 3 minus x squared is less than or equal to 3. I'm adding 3 both sides. That means this is y. So y is less than or equal to 3. So therefore, this is the range. The range is all real numbers less than or equal to 3. Okay, that means whatever you put for x, you'll always get a number which is less than or equal to 3. You will never get a number which is more than 3. Okay, one more example. So let us say let me take f of x equal to 2x square plus, for example, let's say 8x plus 1. Okay, so you can write it as 2 into x plus 2 the whole square minus 7. Okay, if we complete the squares. So again, this is nothing but y for me. So x plus 2 the whole square is greater than or equal to 0. And 2 times that is also greater than or equal to 0. And 2 times x plus 2 the whole square minus 7 is greater than or equal to minus 7. That means y is greater than or equal to minus 7. So this is range of this function. Okay. Now, so we've seen a linear function and a quadratic function. Now for a cubic function, okay, the range is all real numbers. Okay, so you can just close your eyes and say that the range is all real numbers. So okay, so we've seen a linear function, a quadratic function, and a cubic function. So I'm not going to fourth degree or fifth degree function. So let me take a rational function now. So let us say f of x equal to x over x minus 1. Now if you recall, for this function, the domain is all real numbers except 1, and the range is also all real numbers except 1, isn't it? Because we found out that 1 cannot be part of the range. Now how do I find out? Very simple. What you do is you write f of x as y, so y equal to x over x minus 1. Then you need to make x as a subject. So how do I do that? Cross multiply. xy minus y equal to x, xy minus x equal to y, x, take x common, x into y minus 1 equal to y. So x equal to y over y minus 1. As you can see, the denominator, when you put y as 1, the denominator will become 0, right? Therefore, y cannot take the value of 1. Y can take any other value except 1. So for this function, the range is all real numbers, but y cannot be 1. All real numbers except 1. Because if y is 1, then this x will be unreal. Okay, another example. Let's say f of x equal to 3 by x minus 2. Okay, I want to know what is the range of this function. Okay, I hope you know that the domain of this function is, so the domain is all real numbers except 2. So let me find the range. How do I find that? I'll replace f of x with y, 3 by x minus 2. Now I will make x as a subject. So how do I do that? X minus 2 equal to 3 upon y. So x equal to 3 upon y plus 2, which is nothing but 3 plus 2y by y. Now you can see that here the denominator cannot become 0. Therefore, y cannot take the value of 0. Right? So basically, for this function, the range is all real numbers except 0. All real numbers except 0, because y cannot take the value of 0. Okay, another example, f of x equal to x by x plus 2, or let me take x plus 1 by x plus 2. Okay, here the domain is all real numbers except minus 2. Why not minus 2? Because the denominator will become 0. Okay, let me find the range. So y equal to x plus 1 divided by x plus 2. So you need to make x as a subject. So cross multiply. So you get xy plus 2y equal to x plus 1. Now you bring the x terms together. So xy minus x equal to 1 minus 2y. So x into y minus 1 equal to 1 minus 2y. So x equal to 1 minus 2y by y minus 1. Now here you can see y cannot take the value of 1, isn't it, student? Because if y is 1, the denominator will become 0 here. The denominator will become 0. Therefore, for this function, the range is all real numbers except 1. Okay. Another example, another rational function. Let us say f of x equal to x minus 1 by x plus 3. Okay. Or let's say, okay, 2x minus 1 by x plus 3. So here the domain is all real numbers except minus 3. So I'm going to find the range. So y equal to 2x minus 1 by x plus 3. So make x as a subject. So cross multiply xy plus 3y equal to 2x minus 1. So you get, I bring the x terms together, xy minus 2x equal to minus 3y minus 1. Take x common, x into y minus 2 equal to minus 3y minus 1. So x is minus 3y minus 1 by y minus 2. So here y cannot take the value of 2, isn't it? Because then the denominator will become 0. So basically for this function, the range is all real numbers except 2. Okay. So this is how you find the range of a rational function. And of course, in fact, if you noticed, I have not touched upon rational functions whether by the numerator or the denominator is a quadratic or a cubic function. Okay. Now that is it's quite challenging. So what I'll do is I'm not going to do that now, and it is not also part of your syllabus, so you don't have to worry about it. So all these that I'm teaching you right now can be done without a calculator. So in non-calculator, you won't get where the numerator or the denominator is a quadratic or a cubic function or any other function except the linear. Okay, so let me take the square root function now. So let us say f of x equal to root x. So here y equal to root x. Okay. Now here we know that square root of any real number is always greater than or equal to 0. I mean any real number, square root of non-negative real numbers, if square root of 0 is 0, and if it is positive number, then it is positive. So basically for this function, the range is y belongs to R and y is greater than or equal to 0. Yeah. Okay. So another function, another square root function. So let us say f of x equal to root of x minus 3. So y equal to root of x minus 3. Again, this is always greater than or equal to 0. So the range is y is greater than or equal to 0. So it's quite easy to find. So let me give you a combination of functions. Let's say f of x equal to root of x minus 3 plus 4, for example. How do I find the range of this function? Now we know that root of x minus 3 is always greater than or equal to 0. Therefore, root of x minus 3 plus 4 is always greater than or equal to 4. But this is y, isn't it? I'll take this as y. So y is greater than or equal to 4. So this is the range of this function. Okay, so this is actually how you find it if it is a square root function. Now what about an exponential function? Okay, what about, let's say, a power x, where a is greater than 0 and a is not equal to 1. Yeah? In fact, the a cannot be negative. So this is an exponential function. A has to be greater than 0, but a also cannot take the value of 1. Now for this function, I told you that the domain is all real numbers, isn't it? But the range is, for this function, the range is y greater than 0. always a power x will always be greater than 0. Whatever you put for x, even if you put minus negative number, a power minus, for example, let us take f of x equal to 2 power x. So even if you find f of minus 2, it will be 2 power minus 2, which is 1 by 2 power 2, which is actually 4, which is positive. So whatever number you put for x, you'll always get a positive number. So for any exponential function, the domain is all real numbers greater than 0. Okay. So finally, let us look at a logarithmic function. So let us say f of x equal to log x to the base 2, for example. Okay. Now for this function, the range is all real numbers. Now you may ask me, so how do you know that the range is all real numbers? Okay, fine. What I'll do is, I will write it as y. So that means y equal to log x to the base 2. And I hope you know that x has to be greater than 0 here, isn't it? The domain is all real numbers greater than 0 for a log function. Okay. So I have to make x the subject. That means x equal to 2 power y. Now we know that y can take any value. 2 power y will always belong to R. Always. It will be a real number, whatever the value of y may be. So that means y belongs to R. Y is any real number. So therefore, the range is any real number. Okay. So let me recollect. Domain for a polynomial function. For a polynomial function, linear, quadratic, cubic, the domain is R, all real numbers. Now for a rational function, I told you how to find it. Yeah, the denominator should not be 0. And for a square root function, I told you how to find it. Whatever is inside the square root should be positive. Okay. So for example, if it is root of x plus 3, then x plus 3 should be greater than or equal to 0. So x is greater than or equal to minus 3. So the domain is all real numbers greater than or equal to minus 3. And for an exponential function, the domain is all real numbers. And finally, for a logarithmic function, the domain is all positive real numbers. Okay. Here the denominator, DE and denominator should not be 0. Then if it becomes 0 for any value of x, that is not part of the domain. Okay. Now range. Again, for range, for a linear function, all real numbers. For a cubic function also, all real numbers. For a quadratic function, I told you how to find the range. How? Completing, completing the squares. By completing the squares, you can find the range. And for exponential function, the range is all real numbers greater than 0. Okay, let me use y. So for an exponential function, the range is all real numbers greater than 0. And finally, for a log function, it is all real numbers. Okay, fine. Thanks a lot for watching this video, students. I hope you have understood the concept, right? Okay, thank you.